Hello dear students, today we are discussing types of pressure, means absolute pressure, atmospheric pressure and gauge pressure. In last lecture, you studied what is fluid, properties of fluid and pressure. So let us start new point, pressure due to a liquid column. Again here we consider a vessel which is filled with a liquid. Vessel is filled with a liquid. Here we want calculate pressure due to a liquid column. Liquid column means here we consider an imaginary cylinder. Here we consider an imaginary cylinder and the imaginary cylinder exerts weight. This imaginary cylinder also filled with a liquid, and due to this liquid column, what is the pressure on the bottom of the surface of this cylinder we will calculate. So we consider here vessel which is filled with a water. Then it is the interfacing media, means free surface. Interfacing with two homogeneous fluids means air and water. Air and water. Here we want to calculate pressure due to a liquid column. You know the pressure. Pressure means force upon area. Pressure means force upon area. Pressure by the liquid means when fluid exerts force on the surface of the contact when it is at rest position is known as the pressure. So here pressure due to this liquid column on the bottom surface of the cylinder. This cylinder having two surfaces, this surface is top surface, this surface is bottom surface. A is the area of cross section of the top and bottom surfaces. Then h is the height of the liquid column. H means height of liquid column. Height of this liquid column. Then the pressure exerted by this liquid column which exerts on this bottom surface, which is equal to force upon area. Now this imaginary cylinder contains liquid. Then weight exerted by this liquid molecule on the bottom surface of the cylinder is equal to mg. And this force exerted in downward direction. This force exerted in downward direction on the bottom surface of this cylinder. Therefore, F is equal to mg. F is equal to mg. Now, m is mass of the liquid which is in the cylinder. M is mass of the liquid which is in the cylinder and G is the acceleration due to gravity. H is the weight of the liquid column which is exerted in downward direction on the bottom surface of the cylinder. Then pressure is equal to mg upon A. Pressure is equal to mg upon A. Equation number 1. Now M is the mass of the liquid which is in the cylinder. Then you know formula of mass. Mass is equal to rho into volume. Means density into volume. Then volume is nothing but the volume of the cylinder. Therefore, volume of the cylinder is equal to area into H. Volume is equal to area into H. Therefore, M is equal to here rho into A into H. Therefore, M is equal to rho A H. Then mg is equal to rho A H G. Equation number 2. Then from equation number 1 and equation number 2, we get the equation P is equal to mg. Here mg. mg is equal to rho A H G. Therefore, rho A H G upon A. A cancel. P is equal to rho H G. Formula of pressure is equal to rho H G. Again, here we consider this vessel is filled with a liquid. Then imaginary cylinder which is placed in the liquid. Three surfaces interfacing between two homogeneous media means air and water. We want to calculate pressure due to liquid column. Liquid column means imaginary cylinder which is filled with a liquid. इथं बरेच प्रेशर सुद्धा अप्लाय झालेले असतील पण फक्त आपल्याला प्रेशर ड्यू टू दिस लिक्विड कॉलम आपल्याला काढायचं. So pressure due to liquid column means the force exerted by the water molecules which are in the cylinder. So this force is equal to mg. Pressure means force upon area. Therefore pressure is equal to mg upon A. Then m is the mass of the liquid which is in the cylinder. Then m is equal to also density into volume. Therefore volume is equal to A into H. M is equal to rho A H. Then mg is equal to rho A H G. Then from equation number 1, equation number 2, we put the formula of mg in the equation number 1. Then pressure is equal to rho A H G upon A. A cancel, P is equal to rho H G. Means pressure is equal to pressure due to liquid column is equal to rho H G. Rho means density. So we can conclude that pressure depends upon density of the liquid and height of the liquid column. G is the acceleration due to gravity. So you feel excess pressure while swimming under water when you are at the depth, height of depth. So pressure is equal to rho H G. Pressure increases when height or depth increases, rho increases, then pressure also increases. Means pressure depends upon rho and H. Okay, so P is equal to rho into H into G. Then next point is atmospheric pressure. Atmospheric pressure. Atmospheric pressure means the pressure exerted. Atmospheric pressure means the pressure exerted by the atmosphere at the sea level is known as the atmospheric pressure. You know atmosphere contains fluids. Fluid means air. Air is a fluid because it can float. Also atmosphere contains other gases. You know pressure means the force exerted by liquid column. अगोदरचा फॉर्म्युला आपण बघितलेला आहे. आता आपल्याला करायचं atmospheric pressure. So this pressure means the pressure due to air column असं आपल्याला म्हणता येईल. So atmosphere contains fluid means gases and air. So here we consider the surface of the earth. Here we consider surface of the earth and atmosphere exerts force exerts force on the surface of the earth and pressure due to this force is known as the atmospheric pressure. So atmosphere exerts force in downward direction. It exerts force in downward direction and this pressure is known as the atmospheric pressure. So when height increases, that time suppose here height increases, then density of air decreases. You know the pressure means H rho G. P is equal to H rho G and H means height, rho means density. When density increases, pressure increases. When height increases, pressure also increases. But here what happens? Density of atmosphere or air decreases when height increases. So Beyond 8 kilometer, density of air negligible. Density of air negligible. And at the surface of the earth, it is also a sea level. It is also a sea level. So, measure atmospheric pressure at the sea level. Measure atmospheric pressure at the sea level. Atmospheric pressure means the pressure, atmospheric pressure exerted by the atmosphere in the downward direction on the surface of the earth. And when height increases, then pressure decreases. Beyond 8 kilometers, density of air decreases. So, normal atmospheric pressure measured at sea level. Normal atmospheric pressure measured at sea level. This normal atmospheric pressure is equal to 1 atmospheric pressure is equal to 1.01325 Pascal. 1.01325 into 10 raised to 5 Pascal or 1.01325 bar. ही व्हॅल्यू जी आहे ॲटमॉस्फेरिक प्रेशरची ती तुम्हाला लक्षात ठेवायची आहे. सो 1 ॲटमॉस्फेरिक प्रेशर इज इक्वल टू 1.01325 into 10 raised to 5 Pascal. Also 1.01325 bar. So atmospheric pressure means the pressure exerted by the atmosphere at the sea level is known as the atmospheric pressure. It is measured up to 8 kilometers from the surface of the earth. So it is the atmospheric pressure. And 1 atmospheric pressure is equal to 1.01325 Pascal. Now vacuum. Vacuum. Suppose here we consider any region. Here we consider any region. And in this region, the pressure of gas is less than atmospheric pressure. So when pressure of gas is less than atmospheric pressure, then the region is known as the vacuum. म्हणजेच या रिजनचा प्रेशर जो आहे जे तिथं उपलब्ध असतील गॅसेस तर त्या गॅसचा प्रेशर जो आहे तो ॲटमॉस्फेरिक प्रेशर पेक्षाही कमी असणार आहे. म्हणजेच त्या रिजनला आपण काय म्हणणार आहे व्हॅक्यूम. देन ॲब्सोल्यूट व्हॅक्यूम. Here absolute vacuum means, suppose here we consider region. The pressure of this region is also less than atmospheric pressure and matter is absent. Matter means molecule and atoms. They are absent. So this region is known as the absolute vacuum. When matter or molecules or atoms are absent, then region is known as the absolute vacuum. So you know the atmospheric pressure. Atmospheric pressure means the pressure exerted by the weight of the atmosphere at the surface of the earth at sea level is known as the atmospheric pressure. Vacuum means the region where the pressure of gas is less than atmospheric pressure is known as the vacuum. Absolute vacuum means when the region having no matter or no molecule or no atom, then this region is known as the absolute vacuum. So you know the difference between vacuum, absolute vacuum and atmospheric pressure. So you know pressure due to liquid column is equal to H rho G. Atmospheric pressure is equal to 1.01325 into 10 raised to 5 Pascal. Then we will discuss absolute pressure and gauge pressure. या दोन्हीमधला डिफरन्स आपल्याला बघायचा आहे. ऍक्च्युली गेज प्रेशर म्हणजे इट इज दी एक्सेस प्रेशर. म्हणजे आता मी इथं उभे आणि माझ्या सभोवताली एअर जो आहे, एअरचा प्रेशर किंवा ऍटमॉस्फेरिक प्रेशर जो आहे तो एक्झर्ट होतोय, पण तो मला फील होत नाहीये. म्हणजे तो प्रेशर जो आहे ऍटमॉस्फेरिक प्रेशर तो मला फील होत नाही. पण जर माझ्या डोक्यावर जर काही वजन दिलं, ओझं दिलं, तर ते वजन जे आहे ते मला फील होणार आहे. म्हणजे ते एक्सेस प्रेशर जे आहे ते मला फील होणार आहे. किंवा अंडर वॉटर वेन स्विमिंग you feel excess pressure. You feel excess pressure. So this excess pressure is known as the gauge pressure. So this excess pressure is known as the gauge pressure. So here we will see the difference between absolute pressure and gauge pressure. Difference between absolute and gauge pressure. सुरुवातीला आपण पहिला पॉइंट बघितला प्रेशर ड्यू टू ए लिक्विड कॉलम. म्हणजे त्या बॉटम सरफेस, सिलिंडरच्या बॉटम सरफेसला जो काही प्रेशर एक्झर्ट झालेला होता तो फक्त लिक्विड कॉलम थ्रू झालेला होता. आता आपण बघणार आहोत ऍब्सोल्यूट प्रेशर आणि गेज प्रेशर. म्हणजे बाकीचे जे प्रेशर एक्झर्ट होतात ते सुद्धा आपण ह्या पॉइंट मध्ये बघणार आहोत. सो अगेन हिअर वी कन्सिडर ए टँक which is filled with a water. This tank filled with a water. Again here we consider imaginary cylinder. Imaginary cylinder which is also filled with a water. Imaginary cylinder which is also filled with a water. Then three surface interfacing between two homogeneous fluid, air and water. Air and water. Now the reference point is here 0. Reference point is equal to 0. Then cylinder is imaginary which is filled with a liquid. This surface is top surface, this surface is bottom surface. Then pressure applied on this top surface is P1, bottom surface is P2. Which forces exert on this bottom surface of the cylinder? So first surface means top surface. On the top surface, liquid column above the cylinder means liquid molecules which are above the cylinder. Liquid molecules above the cylinder exert pressure on the top surface of the cylinder. So this force is known as the F1. या फोर्सला F1 कन्सिडर करायचं आहे. Then also the force F2 acts in upward direction. Force F2 acts in upward direction at the bottom surface of the cylinder due to the weight of the water molecules which are below the cylinder. Which are below to this cylinder. So two forces, F1 in downward direction and F2 in upward direction. So F1 force in downward direction and F2 in upward direction. F2 in upward direction. Now F1 is in downward direction which exerts on the bottom surface of the cylinder, and this force is due to the liquid column which are above the cylinder. F2 is in upward direction and this force is due to liquid column which is below the bottom surface of the cylinder. Now another force exerts on this liquid column. So it is the downward force and it is the weight of the water molecules which are in the cylinder. So this force is mg. This force is mg. So F is equal to mg, means three forces acting on the bottom surface of the cylinder. Three forces acting on the bottom surface of the cylinder. Which forces? F1 in downward direction, F2 in upward direction, and mg. Now these two forces in downward direction and F2 in upward direction, and water or liquid is in rest position. This cylinder also is in rest position, means it is in static equilibrium. It is in static equilibrium. मग हे दोन्ही फोर्स जे आहेत ते एकमेकांना बॅलन्स करतात, मीन्स अपवर्ड फोर्स अँड डाऊनवर्ड फोर्स. म्हणजेच दोन्ही फोर्स जे आहेत ते इक्वल असणार आहे. दोन्ही फोर्स म्हणजे कोणते? अपवर्ड डायरेक्शन अँड डाऊनवर्ड डायरेक्शन. Therefore, F1 is the downward direction, F is the downward direction which is equal to mg. Then in downward direction, force are F1 plus mg. In downward direction, forces are F1 plus mg. Then in upward direction F2. In upward direction F2. So downward direction force and upward direction force are equal. They balances to each other. Therefore F2 is equal to, here F2 is equal to F1 plus mg. F2 is equal to F1 plus mg. Now you know the formula of pressure. P is equal to F upon A. P is equal to F upon A. Then P1 is equal to F1 upon A. A is the area of cross section of the cylinder, which is same. Then P2 is equal to F2 upon A. P2 is equal to F2 upon A. Then F1 is equal to P1A, F2 is equal to P2A. Therefore, this equation becomes equation number 1. So, equation number 1 becomes F2 means P2A, F1 means P1A. So, P2A plus P2A is equal to P1A plus mg. So, P2A is equal to P1A plus mg. P2A is equal to P1A plus mg. Now, the height of this liquid column is, here we consider top surface at x1 and bottom surface at x2, reference point from the base, and we measure this distance in upward direction. Measure this distance in upward direction. So, the height of this liquid column is x1 minus x2, because x1 is greater than x2. We measure distance in upward direction. So, x1 is greater than x2. Therefore, x1 minus x2 is the height of liquid column. Here, mass means m. M means mass of the liquid which is in this cylinder. So M is equal to, you know, volume into density. M is equal to volume into density. Again, volume means area into height. Volume means area into height. Here volume means it is the volume of cylinder. Then area into height. Height here x1 minus x2. Height of this liquid column is x1 minus x2. So V is equal to A into x1 minus x2. V is equal to A into x1 minus x2. Then V is equal to, again M is equal to V into rho. M is equal to V into rho. V is equal to A into x1 minus x2. Then A into x1 minus x2. M is equal to mg is equal to a into x1 minus x2, then g. Here m is equal to v into rho. V means a h. Then m is equal to v means a h and rho. Then mg is equal to a into x1 minus x2 into g into rho. Rho means density. Density of the liquid. Density of the liquid. M is the mass of the liquid which is in the cylinder. Height of this liquid column is x1 minus x2. आता आपण इथे काय कॅल्क्युलेट करतोय? Pressure which exerted by this liquid column and the liquid which are above the cylinder and below the cylinder. म्हणजे तीन प्रेशर आपण इथं बघतोय. Which exerts on this bottom surface of the cylinder, imaginary cylinder. सुरुवातीला आपण फक्त काय बघितलेले? Pressure which exert on the bottom surface of the cylinder due to this liquid column. म्हणजे फक्त एकच प्रेशर बघितलेलं आहे mg. आता आपण दोन ऍडिशनल प्रेशर बघतोय. So first pressure in downward direction, second in upward direction, and mg also in downward direction. So force F1 due to liquid column which are above the cylinder in downward direction. F1 is equal to P1A. F2 in upward direction due to liquid column which are below the cylinder. F2 is equal to P2A. Mg is the gravitational force exerted by the liquid column, means liquids in the cylinder, on the bottom surface of the cylinder. So it is equal to mg. Then downward force and upward force are balances to each other. Then we can conclude that downward force must be equal to upward force. Downward force must be equal to upward force. Therefore, P2A is equal to P1A plus mg. M is mass. So mass is equal to volume into density. Density is the density. It is the density of liquid. V is equal to AH. Then V is equal to A. H means the height of the liquid column, which is equal to x1 minus x2. Then M is equal to A into x1 minus x2 into rho. Mg is equal to A into x1 minus x2 into G into rho. So it is the equation. So total equation बघणार आहोत आपण. पहिलं इक्वेशन जे मिळालेले आपल्याला P2A is equal to P1A plus mg. P2A is equal to P1A plus mg. So equation number 1. Mg is equal to A into x1 minus x2 into G into rho. Equation number 2. Then P2A is equal to P1A plus mg. P2A is equal to P1A plus mg means A into x1 minus x2 into G into rho. A इथं सगळीकडे कॉमन आलेला आहे त्यामुळे तो आपण कॅन्सल करतोय. A सगळीकडे कॉमन आहे. सो P2 is equal to P1 plus x1 minus x2 into G into rho. P2 is equal to P1 plus x1 minus x2 into G into rho. So we get this equation. P2 is equal to P1 plus x1 minus x2 into G into rho. हे इक्वेशन खूप इम्पॉर्टंट आहे आणि ते व्यवस्थित लक्षात ठेवायचंय. पुढचं जे काय आपल्याला कॅल्क्युलेशन करायचंय त्यासाठी हे इक्वेशन तुम्हाला लागणार आहे. सो P2 means pressure which exerts on the bottom surface of the cylinder. P1 means it is the pressure at the top surface. x1 minus x2 means height of the liquid column. G means acceleration due to gravity. And rho means density of the लिक्विड. तर हे इक्वेशन आपल्याला लागणार आहे आणि ह्या इक्वेशन नुसार तुम्ही ऍटमॉस्फेरिक प्रेशर काढू शकता किंवा प्रेशर इनसाइड दी लिक्विड काढू शकता. ठीक आहे. तर हे इक्वेशन जे आहे ते व्यवस्थित लक्षात ठेवायचे. त्यामुळे हे इक्वेशन आपण इथे लिहून ठेवणार आहोत. पुढचे कॅल्क्युलेशन जे आहे त्यासाठी लागणार आहे. सो P2 इज इक्वल टू P1 प्लस x1 minus x2 into G into rho. Then next point is अगोदर आपण बघितलंय प्रेशर ड्यू टू लिक्विड कॉलम. त्यानंतर आपण बघितले कोणतेही दुसरे प्रेशर जे आहे त्या लिक्विड कॉलमवर एक्झर्ट होतात ते बघितलेलं आहे. म्हणजे ऍटमॉस्फेरिक प्रेशर, टोटल प्रेशर हे सुद्धा आपण काढले. त्यानंतर आपल्याला प्रेशर विथ एक्झर्ट ऑन दी बॉटम सरफेस ऑफ दी सिलेंडर बट ऍट डेप्थ आपल्याला काढायचे. सो अगेन हिअर वी कन्सिडर सिलेंडर. Here the vessel which is filled with a liquid and the cylinder, imaginary cylinder whose height is h. Now reference point is here, this reference point is this line, reference point. So it is 0. It is 0. Okay. So height. Here we consider height means depth. जरी h नाव दिलेलं असेल तरी इथं आपण काय म्हणणार आहोत डेप्थ. सो डेप्थ we measure in downward direction. We measure in downward direction. So this depth is in negative. ही डेप्थ जी आहे ती कशी येणार आहे निगेटिव्ह मध्ये येणार आहे. त्यानंतर टॉप सरफेस. टॉप सरफेस एक्सपोज टू दी ऍटमॉस्फिअर. सुरुवातीचा सिलेंडर जो आहे त्याचा टॉप सरफेस जो आहे तो लिक्विड मध्ये होता. पण आता टॉप सरफेस, this top surface exposed to the atmosphere. So the pressure must be at here. Atmospheric pressure means P0. सुरुवातीला आपण बघितलं इथं प्रेशर जो आहे तो आपण इथं P1 कन्सिडर केलेला होता. सो दिस P1 इज इक्वल टू P0. म्हणजे इथं ऍटमॉस्फेरिक प्रेशर एक्झर्ट झालेला आहे कारण हा सरफेस जो आहे तो ऍटमॉस्फेरिक प्रेशर ऍटमॉस्फिअर मध्ये येतो. त्यामुळे इथं ऍटमॉस्फेरिक प्रेशर जो आहे तो काय झालेला आहे एक्झर्ट झालेला आहे. त्यानंतर बॉटम सरफेस म्हणजे टोटल प्रेशर आपल्याला इथे काढायचंय ऍट डेप्थ एच. सो या पॉइंटला प्रेशर काढायचं ऍट दी बॉटम सरफेस ऍट डेप्थ एच. म्हणजे हा प्रेशर जो आहे तो P2 आहे. हा प्रेशर जो आहे तो P2 म्हणजे टोटल प्रेशर असणार आहे. सो P2 इज इक्वल टू P. P2 इज इक्वल टू P असणार आहे. त्यानंतर आता आपण हे इक्वेशन बघणार आहोत. P2 इज इक्वल टू P1 प्लस x1 मायनस x2 इंटू G इंटू रो. मग P2 म्हणजेच काय P. सो P. देन P1 मीन्स P0. P0 प्लस x1 काय इथं 0 आहे. x1 काय असणार इथं 0. हा रेफरन्स पॉइंट आहे त्यामुळे x1 0 घेतलेला आहे आणि x2 जो आहे तो असणार आहे मायनस h कारण डाऊनवर्ड डायरेक्शनने आपण डेप्थ जी आहे ती मेजर करतोय. सो P इज इक्वल टू P0 प्लस 0 मायनस h इंटू G into rho. Therefore, P is equal to P0 plus H rho G. Therefore, P is equal to P0 plus H rho G. So, T means total pressure, P0 means atmospheric pressure, and H rho G pressure due to liquid column. मग हा जो टोटल प्रेशर आहे त्यालाच आपण ऍब्सोल्यूट प्रेशर असं म्हणतो. P0 म्हणजे ऍटमॉस्फेरिक प्रेशर आणि H rho G म्हणजे गेज प्रेशर. सो टोटल प्रेशर is equal to atmospheric pressure plus here gauge pressure. Okay, so P means absolute pressure. P naught means atmospheric pressure, and H rho G means gauge pressure. Gauge pressure. म्हणजे या इक्वेशन वरून आपण ऍटमॉस्फेरिक प्रेशर काढू शकतो, ऍब्सोल्यूट प्रेशर काढू शकतो आणि गेज प्रेशर काढू शकतो. जर आपल्याला ऍटमॉस्फेरिक प्रेशर काढायचं असेल किंवा गेज प्रेशर काढायचं असेल तर या पद्धतीने इक्वेशन येणार आहे. P नॉट इज इक्वल टू P मायनस एच रो जी. किंवा गेज प्रेशर काढायचं असेल एच रो जी इज इक्वल टू P मायनस P नॉट. म्हणजे या पद्धतीने हे इक्वेशन वापरून आपण atmospheric pressure किंवा gauge pressure काढू शकतो. So total pressure means absolute pressure is equal to atmospheric pressure plus gauge pressure. Okay.